Welcome to the second part of our three-part 360-degree tour of one of PGE's distribution substations. Just as in part 1, the 115 kV transmission line and monopole directly ahead and now in the distance will serve as our anchor point. We'll begin this section of the tour by covering an important safety feature of a substation. By swiveling to the right of the anchor point, you can locate switch mats at the base of any manually operated switches. These switch mats are here for operators that have to manually work on the switches. When an operator stands on a switch mat, the mat ensures the operator is the same potential as the equipment they are working on, thus preventing them from being severely burned by current or from, dying. Now, if you move your camera up, right in front of you, you will notice the set of V-brake center switches that we covered in part 1, which can be utilized to isolate the sides of the substation when necessary. If you continue to move your camera around to the right, you will see another set of V-brake center switches, and like the ones from part 1, these are here to isolate the equipment so work can be done on it. Although these switches can be remotely activated through supervisory control, they can also be manually opened and closed while on site. This manual control is called a gang switch. The operator would be standing on the adjacent switch mat for safety to manually operate the gang switch. If you look closely at the top of these V-brake center switches, you will see what's called a whip and horn. High-speed arcing horns and whips are the equipment added to the disconnect switches to allow them to interrupt small amounts of charging or magnetized current. These two structures are used to dissipate voltage and a little bit of current, as well as being used to save the switch's contacts. The keen observer might note that the whip and horn are only on these brakes and not on the other previous V-brake center switches we covered in part 1. Why is that? The reason is because this breaker is located right next to our transformer. A transformer contains an enormous amount of copper wire that is coiled around an iron core. Because of the magnetic fields created by these coils, if this switch were to open to break the current, the sheer strength of the magnetic field coming from the transformer has the possibility of keeping current flowing by arcing through the air. So the whip and horn are here for added insurance to help break the circuit. Next to this set of V-brake center switches is another circuit switcher or breaker. You can think of this particular breaker as a smart switch, whereas the previous switches could be either manually or remotely opened or closed. This smart switch can do so automatically, based on predetermined conditions like faults or voltage levels. The box connected to the side is the control box for that circuit switcher. As the name suggests, the control box is used to make adjustments to the automated behavior of the switch. And as we previously showed, the next piece of equipment to the right of the circuit switcher is the transformer. We'll go into greater detail about the specifics of the transformer in part 3. Until then, all the labels have returned to each device, and you can once again look around and familiarize yourself with the structures. Once you're ready, be sure to check out the third and final part of this tour in the next video.